Dear students, up till now we have studied the combinational logic circuits and the flip-flop, that is the memory element. Now we are going to study sequential logic circuits. A sequential logic circuit is made up of the combinational logic as well as the memory element. So you can see in the block diagram, this block diagram is showing a basic sequential circuit. One part is the combinational logic, another one is the memory. So separately inputs are given to combinational logic along with the memory values to get the combinational outputs, and combinational logic interact with the memory element. So we can say that the current state of the sequential logic is value stored in the memory elements, and the state of the sequential circuit changes. We can say the state transition in the sequential circuit occurs when a change in the stored value in the memory element which changes the circuit from one state to another. So this was about the sequential circuits. Now we are going to study various sequential circuits like registers and counters. Our first element of the sequential circuit is registers. Now you can see the classification of registers. Let us see, we will see what is a register. A register is simply kind of register which stores the data. It means register is a group of memory elements that work together as a unit, and the simplest register do nothing more than to store a binary word. We can modify the store word by shifting its bits left or right by performing other operations which we will discuss later on. So there are two types of registers, buffer register and shift register. As I explained, the register is nothing but a device, a logic circuit which stores the data, binary data. When data is simply stored in a register, the register is called buffer register. When data can be shifted in the register, shifted inside outside, it is known as shift register. So shift registers are of four types: serial in, serial out, SISO, serial in, parallel out, SIPO, parallel in, serial out, PISO, and PIPO, parallel in, parallel out. So all the four combinations of the registers block diagram is shown here. How the data is shifted at the input and received at the output. The first one is the PIPO. Parallel data is, we have shown the 4-bit register. Parallel data is taken as input and we are getting all the 4 bits at the output. So this is a 4-bit register. It can store 4 bits inside it. Parallelly data can be stored, 4 bits parallelly can be stored and can be read. Second type of register, parallel in, serial out. So this is parallel input, 4-bit parallel input, and we are getting serial output. One by one 4 bits will be shifted out as a clock is received by the circuit. Another type of register, shift register, is SISO, serial in, serial out. It means serial input is there, serial output is there. 4 bits will be inputted serially one by one, bit 0, bit 1, bit 2, bit 3, and will be received in the same sequence, bit 0, bit 1, bit 2, bit 3, as the clock pulse is received. Another last step of a register is serial in, parallel out register. Input is serial, as we have said, serial in. So serial input will be there, parallel out, so parallel output is available. So one by one 4 bits will be inserted serially or given as the input serially in the register, and parallelly 4 bits can be read as an output. So these are the 4 configurations of the shift register. Now we will see, as we have said that the register is nothing but a group of memory element working together as a whole unit. So it says that a shift register, simply a register, must be comprises of a memory element. What is our basic memory element? That is the flip-flop. So let us see the diagram, circuit diagram. See, this is a 4-bit register. This is a buffer register. Data cannot be shifted here left to right or right to left. So you can see in the diagram that D0, this is a D flip-flop. This is the block diagram, symbolic D flip-flop. We have seen all the symbols of the flip-flop in the previous lecture. So this is D flip-flop, D flip-flop, D flip-flop, D flip-flop. So we have taken 4 D flip-flops at every input of a D flip-flop. This is C, D0, D1, D2, D3. What is the input? We are seeing that this is a parallel in, parallel out type device. So parallelly all the inputs are given. Say input is X. So X is comprised of 4 bits, X0, X1, X2, X3. And this is a synchronized circuit. It is having a clock. 1, 2, 3, 4. All the D flip-flop having a clock. As X0, X1, X2, X3 is received by the D flip-flop, the output state changes Q0, Q1, Q2, Q3. So whatever is the input, their same is the output. So if X0 is the input, D0 is equal to X0. If X1 is the input, Q1 is equal to X1. If X2 is the input, Q2 is equal to X2. If X3 is the input, then Q3 is equal to X3. It means that Q is equal to X in a buffer register. I think the working of the buffer register is clear to you. In the next class, we will see how a controlled buffer register can be used. What is its purpose? My questions are, can you draw 8-bit buffer register? Assignment question is, draw 8-bit buffer register and write all the classification of the register. Submit this assignment in the group of your class.